Welcome back to Module 3, Algebra 1 lesson. Today we're going to talk about linearity and continuity of graphs, and I wanted to start with this little warm-up. I think it's a good activity. We're trying to determine if they're linear or nonlinear. So we're not going to do all of these, but I just want to give you a little hint on how you go about doing that. Look at the change from one number to the next. We can tell with this top one, it's going up by 20 each time. And as the width goes up by 20, the bottom number is going up by, let's see here, that would be 2,200 each time. Well, from here to here, it goes up by 2,200. But from here to here, I don't think that's a change of 2,200. So from 7,000 up to 9,600, that's going up by, what is that, 2,600? So it's not a consistent change. Therefore, that would not be linear. If we look at this, it's nonlinear. If the change is the same each time, then it is linear. So looking here, as it goes up by 1, this goes up by 0 each time. The change is constant. As x goes up by 1, y is going up by 0 every single time. Here, we're going up by 0.25. As we go up by 0.25 from here to here, this goes up by, let's see here, what would that be? A half. Well, then you look at this goes up by another half, and what does this go up by? Another $1.25. So we went up by $1.25, $1.25, or an inch and a quarter, whatever, we're talking about length, and here it's going up by half an inch each time. So it is linear, and that is how we determine whether something is linear or nonlinear, by looking at a table. All right, so let's move on to our next resource. We're going to talk about, again, linearity and continuity of graphs. So when I see the word linearity, I see the word line hidden in it, L-I-N-E, linearity. So I know that we're talking about straight lines.
One grain of rice, a mathematical folktale, tells the story of Rani, who tricks a greedy Raja into giving her rice for her starving village. She tricks him by asking him for a seemingly small amount of rice, 1 grain the first day, then double the previous day's amount for 1 month. After 30 days, she has over 1 billion grains of rice for her village. She would have had to ask for over 35 million grains each day for 30 days to gain about the same amount. How could the amount of rice grow so quickly? Let's look at these numbers in a graph. If Rani had asked for 35 million grains each day, a request the Raja would have denied, then the total amount of rice would increase by the same number each day, 35 million. Instead, Rani asks for increasing amounts each day, specifically double the amount of the previous day. This can also be represented with a graph. This graph represents the total amount of rice per day for this relationship. It's amazing how the growth starts out so slowly, but eventually Rani gets more rice this way. These two graphs represent two different types of functions. The first graph, where Rani receives the same number of grains per day, is a linear function. The second graph, where Rani receives twice as many grains as the day before, is a nonlinear function.
All right, so there we see the difference between linear and nonlinear. We've got today's standards, FIF4 and FIF5. And then the vocabulary, very important to get this written down somewhere. We're going to talk about discrete, continuous, linear, and nonlinear. And I'll explain these more as we go, but discrete just means the points aren't connected. It's just random points on a graph. Continuous means the points on the graph are connected. It's an unbroken curve. And of course, linear is a straight line, and nonlinear is a set of points that do not lie on the same line. So let's look at this. We're going to learn about discrete and continuous functions. So the points here are not connected. Therefore, this is considered a discrete function. If we look here, It's not linear because it's on a curve, but the points are all connected, therefore it is continuous. And then every once in a while we have functions that are neither discrete nor continuous. We'll look at step functions later on this year. We will talk about parabolas like this, and we'll only focus in maybe on certain parts. So the graph is broken, which makes it be neither discrete nor continuous. Okay, so when I'm looking at the domain is all of the x values. So in a discrete function, it's just all of these random x values. But looking at the x values for the parabola, it's all real numbers because it just keeps on going forever and ever and ever out this way. And it's going to vary depending on where our line is broken, where there's holes in the graph for one that's neither discrete nor continuous. And with my range, again, it's a set of individual values. Here, my range depends on where my graph starts. So it looks like my range starts here at -5. Remember, the range is the y values, and it goes up. And here, I'm going to have a range from this point down and from this point up. So it looks like from 5, my range would be from -5 to -infinity, and then from 5 up to +infinity, but nothing in between. All right, so that takes care of that. Let's look at an example. We're going to determine continuity based on the situation. It says the Bargain Book Barn sells young adult novels on a sliding scale. That is, the more books you buy, the cheaper they are. Let f of x model the store's prices for given quantities. So I know right off the bat this probably is not going to be linear since they're giving you a deal. The more books you buy, the cheaper the price. So one book costs $1.50, but two books, if we're going one book, that should be $3. But if you buy two, they give you a little bit of a deal. It's $2.90. If you buy 3 books, it's $4.30. 4 books is $5.70, and 5 books is $7.10. Now, thinking about this in the context of the situation, it wouldn't make sense to connect the points because you're not going to buy half a book. You're not going to buy somewhere in between 1 and 2 books. So that's why this is a discrete function, because you're not going to buy a part of a book for somewhere in between, like 1.5 books, somewhere in between $1.50 and $2.90. So this is a discrete function because it wouldn't make sense to connect the points. Looking at the next example, we're going to determine continuity. It says determine if they're continuous, discrete, or neither. Well, this looks to me like it is continuous. All of the points are connected with a line. So this function is a continuous function. This one is neither discrete nor continuous because from here to here it's continuous, from here to here it's continuous, but then I've got this point out here all by itself that's discrete, so we can't specify it as being one or the other. There's not a single line or a single curve, so it's neither discrete nor continuous. So, how do we apply this? Well, as a private investigator, Tia charges $25 an hour for any amount of time up to 8 hours. Then after that, she charges a flat rate of $250 per day. Use the graph to determine the function that models this situation, determine if it's discrete, continuous, or neither. Again, I want to go with neither because from here to here, she's charging a certain amount per hour, so it's continuous up until you get to that 8 hours. Then after that, it's just a flat rate of $250 a day. So at that point, it becomes discrete. So from day 1 on, we could say it's discrete if we ignore the first 8 hours. Or if we just look at the first 8 hours, we could say it's continuous. But because we're looking at the entire piece, it's neither discrete nor continuous because there's elements of both in the graph, if that makes sense. All right, I'm going to stop this video there and I will record another one for the next day. So it's not so much to take in all at once.